We're both affiliated with Texas A&M. I'm a professor at Texas A&M, and Shishir is a postdoc that's working in my lab. And want to describe for you what we think is some really interesting research. So we're going to do a tag team presentation. Most of the research you'll be hearing is actually work that Shishir has led. So he'll be describing that. And I'm just going to give kind of a big picture overview. So the question is whether or not this, what we call thicketization of the Post Oak Savanna is actually reducing groundwater recharge. And hopefully it will become clear to you through this presentation what we're trying to do. So Gary described that you guys are all about preserving prairies. And so this work is really part of a much larger research program, but it's interesting to me when we think about the Great Plains. Most of us envision wide open landscapes, not a tree in sight. In fact, I did a Google search on Great Plains, and just hear some of the images that came up. You can see that, again, all wide open grasslands, no woody plants. Well, what's the reality? So the reality is that this landscape has been pretty rapidly converting from grasslands to woodlands. And this has been happening at least for 150 years, but it's still actively occurring. This is an image from some recent research just showing how much woody plants have increased across the Great Plains just since 1990. And what you see is that, you know, in this 30-year period, in some places, woody plants have increased by 30%. So we'll be talking about the Post Oak Savanna, and the Post Oak Savanna is this area, including this area J, and according to this analysis, there's about 4,000 more square kilometers of woody plants than there were in 1990. Just to drive this point home, and again, all of you being naturalists and pretty attuned to the landscape, I'm sure you're already aware of this, but you know, Texas now is basically a savanna state. There are few grasslands that are remaining intact, and these are just some examples, different ecological areas in Texas. The Edwards Plateau has been converted largely to juniper and oak woodlands. In the mesquite, the upper rolling plains, now largely mesquite savannas, the same with South Texas. So again, the point is that virtually all of the state is really undergoing this phenomena that we call woody plant encroachment. And so this is a larger research question that our lab has been focusing on, is how does this conversion from grasslands to woodlands affect things like how much water is available in streams and groundwater recharge, carbon budgets, and the like. So it's an enormous landscape change that we're trying to understand. And we evaluate it using all kinds of different techniques. These are just some photographs from different field experiments that we've done, but we can use isotopes in rivers as tracers. We instrument small watersheds, do rainfall simulation, tracing experiments, micrometeorological studies, and even look at long-term trends in rivers. And we've been focusing mainly on other parts in the state, but recently we've become very interested in the Post Oak Savanna. And I'll explain the reasoning for that. But so here's a picture from the Gus Engling Wildlife Management Unit. I'm guessing that this is the largest intact true savanna that's remaining in the Post Oak Savanna. They manage about 11,000 acres. And so this is what we imagine that the Post Oak Savanna used to look like in the past. As Gary was explaining to me, I know all of you are very interested in fire and the use of fire, and I'm sure that you appreciate that the only way you can have savannas like this is if you've got fires. Well, the Post Oak Savanna is really one very highly altered landscape. Again, as I know all of you can appreciate, there's a varied land use history. I am pretty sure that much, if not most, of the Post Oak Savanna at one point was cotton fields. Eventually, those were abandoned and shifted to pastures because of changing land use and different changing ownership. Much of this land has been allowed then to naturally revegetate, but it does not come back into savanna. It comes back into what we call these thicketized woodlands. And so our question is, how is that influencing groundwater recharge? And so we're using a number of different techniques, but really one of the first things that we've done is really try to do an analysis of just how much has the Post Oak Savanna changed since 1986. And they were 1986 because that's when the first Landsat images were available. So this is a comparison of 1986 to 2021. What the images highlight is that there is increased woody cover, but using I have another PhD student who's using quite sophisticated remote sensing analysis, and he can determine how much of this is evergreen, which might be either yopon or cedar, how much is purely deciduous and how much is mixed. But really the bottom line is that especially in the northern part of the Post Oak Savanna, there's been quite a substantial increase in woody plants. So this is my last slide, but one of the reasons why we are pretty confident that this is having a large impact on groundwater recharge in the Carrizo Wilcox is that the Post Oak Savanna, the western border of the Post Oak Savanna, exactly corresponds with the Carrizo Wilcox recharge zone. So this Carrizo Wilcox recharge zone is this large sand formation that sweeps from southwest Texas to northeast Texas. It's a sand formation that comes to the surface, and this is where most of the recharge occurs for this Carrizo Wilcox. And the Carrizo Wilcox, if you're not aware, is a incredibly important aquifer for the state of Texas. It's the third most important aquifer behind the Ocala and the Edwards aquifer, but it underlies 66 counties. It's important for irrigation and municipalities. And also, especially important is that it's declining, it's becoming depleted. So the research question that we are asking is, to what extent is this change in woody plant cover potentially reducing groundwater recharge? So with that, I will hand it over to Shishir. I'm going to do a stop share and let Shishir take over. Can you still hear me, Gary?
Thank you, Brad.
Okay.
Can everybody hear me?
Yes.
Okay. For some reason, my video is not working because I'm connected to a different screen. So I will just be, I will not be able to turn on my video. Sorry about that. But thanks, Brad. That's a pretty good way to set up the. Thank you for the invitation as well. Thank you for including me in this presentation, and I'm happy to share what I have through my research so far. So, just a second. Okay, is my screen visible?
Yeah, we're seeing your screen. Yep.
Okay. So I just wanted to start off. So my talk is going to be mostly about looking at the impact of thicketization on groundwater recharge, and more specifically, soil moisture and deep drainage, and a work which was published not too long ago. And before I start into that, I wanted to just share what I imagine as thicketization, and there's of course across the state we see different forms of thicketization. The picture on the top left here is a picture from outside of College Station, and that's just a poster filled with an understory of yopons, Then this is a picture of in the Milam County where there's eastern red cedars alongside Post Oak, and both are growing pretty well. And in fact, there was also some mesquites in there. So that's another implication of just, I guess, management or lack of management or abandoned landscapes just going into a woody chaos. This is a picture of Yopon thicket from inside, and just to, I mean, I've seen even worse than this, and I'm sure a lot of you have also seen worse than this. This is another picture where Chinese privet has been growing back into some open areas despite prescribed burns in that place. This is a picture from grass angling where, again, prescribed burns have been done in some places and grasses are coming back, but also our myrtles and some other shrubby plants are coming. And even in other open areas, grasses are not coming back, but ferns are really populating a lot of understories. So several forms of woody plant encroachment, thicketization across this system. And just to imagine the scope of different kinds of effects, hydrological effects we could be seeing, and which is going unmeasured. Our study site for which was a part of my dissertation work, was in Milano, in Milam County. It is situated on Post Oak Savanna and in Post Oak Savanna and on Carrizo Wilcox, our crop zone. We have this is a picture where we have delineated the Post Oak Savanna. This band here, we just saw that shape which Dr. Wilcox shared in his presentation. These were the sites where I conducted these were the different locations where I did my measurements from, and my measurements were mainly included taking soil cores up to 270 centimeters of depth, and also conducting soil moisture measurements using neutron moisture probe. So this was a dense, thick woodland with a lot of Yopon cover under post oaks. This was sort of like what I identified as a woodland mosaic, which had eastern red cedars, post oaks spread across with a lot of intercanopy spaces. This was a pasture, and this was an eastern red cedar post oak woodland adjacent to an open grassland area. So again, just to give a idea of what these different sites look like. So I basically chose my design where I went from a thicketized woodland, a dense thicket, to a very open site, which was the pasture, site 3 pasture. So these are the two extremes. Site 1 and site 3 are the two extremes. At every site, I tried to contrast. So right next to the oak woodland thicket, I had an open bare site as well. And then there was a woodland mosaic site. Then, as I said, the juniper woodland, which was sort of slightly open inside, but more representative of a forest stand. And that was contrasted with an open herbaceous patch next to it. We took soil samples to measure chloride concentrations from surface all the way to 270 centimeters depth. We did soil moisture measurements and discrete time intervals starting in July 2020 to August 2021. And the measurements were done so that we were taking dry phases as well as post-rain events, and if there was an extended wet period. So we were able. So the idea was to be able to capture the different variations in soil moisture and different points. And the idea of chloride concentrations, before I get into what I found out and what the implications are, I wanted to just go over what these measurements mean and why do we do this. So it will get a little bit technical, but I'll try to explain as best as I can, and also try to keep it simple. So to begin with, we do chloride mass balance measurements or chloride concentration measurements because it is one of the most robust measurements for estimating historical groundwater recharge rates, or more simply, historical movement of water through soil, because chloride does not react chemically or gets used biologically by anything. So it remains preserved, and as a result, chloride keeps accumulating or keeps washed down the soil profile. And what happens, it depends on the vegetation. So if we have vegetation which allows a lot more evapotranspiration, which is with woody plants, we tend to see a slowdown of chloride and it tends to accumulate. So in this case, in this figure, as you're seeing, it's a high concentration. In case there's not enough rooting zone and there's a less ET demand and there's still a lot of rain, then that chloride is going to run further down the horizon and it's going to accumulate at a further deeper point. So as a result, when we take chloride concentration measurements, we can use that to tell what has been happening in a certain point over a longer time period. Over a longer time period also depends on how much rain does a place get, how much sands it is, or how fast the water moves in that place. And everything we measure, the chloride concentration, is then equated with how much atmospheric deposition a place is getting, which is measured through a network of measurement sites set up by the EPA, their National Atmospheric Deposition Program, and that is the reference point for chloride deposition rates. Then again, what it tells us quite a few things, but more simply, going from a forest to a grassland recharge generally is expected to increase because there's less ET demand, but it could come at other costs too. So Bridget Scanlon's work has established that when we convert shrublands to croplands, depending on what kind of management was done on a landscape, you can have an increased mobilization of salts and two, which could be also harmful. So there are trade-offs associated with this too. But in general, it's fair to assume that we could see an increase in soil water movement once we have less woody cover or less rooting depth, to say. Again, so this is a sample. Sorry.
For those of you who may not be familiar with some of the hydrological abbreviations, but ET is just transpiration. So it's just water that's being pumped out by vegetation. So just for in the most simple level. And I just would kind of add or emphasize, so basically this chloride technique is really valuable and useful, is that it's a natural marker or a natural indicator of long-term average groundwater recharge. So the simple way of imagining, if chloride is accumulating in the soil, that means there's very little groundwater recharge. If chloride is washed out of the soil, it means that there is quite a lot of groundwater recharge. And of course, I'm simplifying to a great extent, but that's kind of the most basic way of describing what this technique does.
Yeah, So thank you, Brad. Yeah, so in more, that's a very simple way to understand, and that's a very good tool for if you don't, I tend to get into the details, but yes, if you have very high concentrations, yes, you have very low recharge rates at that point. And if you have low concentrations, that is an indication that the water has been running down pretty fast. And this is just a sample data set from an old work by Bridget Scanlon, who compared some croplands with Mali shrublands. This was in Australia, and this is US high plains, where grassland was compared with croplands. One thing which I would like to point out is a lot of this work has been done in US high plains, but a lot of the work has still not captured what happens when land management and land cover changes on small scales. And that's the scale we are addressing. And that is within a woodland pasture, what happens in one point where there is extreme thicketization at one point which has remained open for a long time. So going back to my research site, which was in Milano, it was a woodland pasture. which had all different kinds of vegetation within a short distance. I got my chloride measurements from all these points, and within, so just keep in mind that this is a very small part of the landscape we are looking at, and within that we saw that the thicketized woodlands had extremely high concentrations of chloride at 270 centimeters, starting from 150 centimeters. And as opposed to the open sites, which had extremely low concentrations of chloride. Pastures had some of the lowest concentrations, so did the other two open sites. Woodlands tend to have more concentration, but thicketized woodlands still have the highest of all the woodlands. So this also suggested that not just thicketized woodlands, but not just woodlands, but it's actually thicketization which worsens the rate of movement in soil profiles. So even under woodland mosaics and average sort of like somewhat open woodlands, you may see some water movement to 300, 320, or 350 centimeters, but but in thicketized woodlands, we do not see any movement of water. We can use all this data to a model where we can equate this for measuring the recharge rates. And this is a plot showing the deep drainage rates at 270 centimeters for the different parts of the landscape, which is where, as suggested by the chloride concentration, the site one open site had extremely high fluxes in some points. Even the lower fluxes were 2 times or 2 orders higher than what we saw in thicketized woodlands. Woodland mosaic had the highest high variability, which was also expected given that it has some open sites and wooded sites. Pastures in general consistently reported higher recharge or deep drainage rates. Do note that this is deep drainage rates. This is not recharge rates. So deep drainage is basically the water rates, the water movement rate beyond the root zone. This is not into the aquifer, because to get to the aquifer, we will have had to take a course which would have gone down to more than 10 meters. This was only done within 3 meters. But this is still a very good indication that what is going beyond 270 centimeters is very little. So recharge is most likely nothing in thicketized woodland. Brad, would you like to add anything?
No, just to emphasize. So again, the message is that with thicketization, basically groundwater recharge does not happen at all. And in open pastures, it may be up to 100 times higher than what we see in more wooded sites. So this is really, we're arguing a strong indication that vegetation basically shuts down groundwater recharge. And this is pretty remarkable given that this is the recharge zone of the Carrizo Wilcox. At least with this preliminary study, and Shishir is going to be describing some ongoing work where we want to really verify this, but this preliminary study really strongly suggests that thicketization basically completely shuts down groundwater recharge, which we are arguing has really important implications, given that these Post Oak Savanna basically overlies the recharge zone of the Carrizo Wilcox. So that's.
Thank you, Brad. Yeah, so just to add to that here, one thing to think about here is that the diminishing of recharge is mainly because of evapotranspiration demand, and which I also saw evidence that the soil moistures inside the thicketized woodlands were pretty low. In fact, they were even dry for a lot of times. I saw extremely saturated soils in the pastures. So it's very evident. It was very evident that transpiration makes a huge difference in these landscapes. Just to show a snapshot of the soil moisture data set, this is just comparing the thicketized woodland with the pasture site. And This is from summer to winter, July 2020 to Feb 2021, and this is from May 2021 to July 2021. On the y-axis, we are seeing the depth going from 0 to 300 centimeters, 0 to 300 centimeters, so that's 3 meters. Same here. The moisture content is basically 0% to 30%. And to make it easier, you could just focus on this part of which is the lower, sort of beyond 1 meter, what's going on. And in both cases, we are seeing pretty high water content compared to woodland. So 20%, 25% mark, 20-25% mark, and this is where we are. We are under 25% here. We are exceeding 25%. We are exceeding 30% water content in some points, and same here too. So again, to emphasize, it's really the soil moisture which gets used up, which in other case, in absence of rooting, in absence of transpiration demand, has a chance of percolating further. Revisiting what's this, and I just want to emphasize again sorry about that, that this was a consistent trend. So in our thicketized woodland, this was a case for all the profiles. We had high concentrations of chloride. In woodland mosaic, it was pretty variable. So that again suggests that woody plants make a difference. Open sites maybe not make so much difference. Open sites were consistently low concentrations. So just the fact that our multiple cores showed similar variabilities or similar trends suggests that our observations were, are pretty robust. Again, at this point, I just want to acknowledge that what we have done in our work is mostly show that the pastures in comparison to thicketized woodlands have higher water retention or have higher recharge rates perhaps. But what we do not have, we have not been able to capture in this study is what happens in a prairie, what happens in a true grassland. What if these post oaks were thinned and burned and seeded to somehow restore grassland state? What happens in those situations? So for that is something which we want to really capture in our next phase of the work, where we are doing work in currently mostly in Gus Angling, which is wildlife management area in Anderson County. We are also doing some work in College Station, where we have an ecology and natural resource teaching area, which is a part of Texas A&M. And I'm just going to visit quickly what we are doing and what we're trying to accomplish through those and through the ongoing work. So these are some pictures of some more coring we are doing currently in Gus Angling. This is just to show the pictures of what cores look like. We take cores in 20 to 30 centimeters undisturbed cores. This is a core from a grassland about 100 centimeters when it was pretty saturated. These bands you can see as the water was moving. This is in a woodland site where it was more than 200 centimeters. Undergraduate students who have been incredibly helpful to have. We have Grady, Hayden, Sam Allred. Jordan has just started as a PhD student, and they have been very instrumental in carrying out this work further. So more work we are doing is we are setting up soil metric potential sensors. Soil metric potential sensors basically capture the tension at which water is held in soil. And this data can be used to measure, to incorporate into models where we can look at how fast water is moving through a soil profile. Another PhD student here, she is putting a sensor in the ground. We put sensors up to 100 centimeters, that's about 1 meter, until 1 meter, and we continuously log that data. In College Station, we are just starting to set up soil moisture measurements in thicketized woodland compared to grasslands. A lot of burn treatments have been done in College Station, so we are going to use those sites as well. One of our undergraduate students did work from 2020 to 2020 measuring interception rates under Yopon. So we have just started to build up on that. What we had seen earlier was that interception losses in under Yopons can exceed up to 40 to 60% for small rainfalls. And granted, this when we did this study, this was done at a very coarse scale of rainfall. So now we're trying to improve this study and incorporate more details such as canopy structures, having more including clusters compared to cleared woodlands, a woodland mixed with eastern red cedar, a dense Yopon woodland. And so that is hopefully going to give us very good interception data in terms of what kind of structure of Yopon is going to affect, how is it going to affect our interception rates.
Again, for all you non-hydrologists out there, interception is basically just the water that's captured by vegetation. So vegetation will, the water will not make it to the soil. It will be captured by the leaves and then be evaporated. So that is what we mean by interception. And it can actually be quite significant, that up to 40% of rainfall can be captured by vegetation and then transpired without ever making it to the soil. So this could be another way that the Yopon is reducing groundwater recharge. And
that's the bulk of the ongoing work right now. We're still working on expanding into some other sites. And I just recently, last month, I visited the Yegua Knobs Preserve with the Pines and Prairies Land Trust. Hopefully, we will be able to start something there soon. But one of the main goals for this work is to be able to find more prairie sites, more sort of true grassland sites, and be able to contrast that with thicketized woodlands, and hopefully make a case that a restoration can possibly increase hydrological services. All right, and that's it from me. And if anybody has any questions, I'll be happy to take.
Well, yeah, I just might add something. So if our hypothesis is borne out, where this could possibly lead would be potentially state government or organizations like the NRCS perhaps providing incentive programs for landowners to do prairie restoration and to reduce thicketization. That's obviously a long way down the road, but this is where we're potentially imagining that what some sort of implications could be, that we'll be using some pretty sophisticated hydrologic modeling to try to determine across the Carrizo Wilcox recharge zone just how much is recharge being diminished as a result of this change in land cover. Gary, I think with that, that's pretty much kind of an overview of what we're doing. I'm happy to entertain any questions or comments from anybody.